You take a breath right now without thinking about it. In, out, automatic. Your brain has been doing this 10 million times without asking your permission. But there is one molecule on Earth that can walk into your brain, find the exact switch that controls that breath, and turn it off. Not in hours, not in an emergency room countdown, in minutes. This is fentanyl. And the story of how it became the deadliest drug in modern history is not really a story about chemistry. It is a story about your brain and a trick it has been playing on humans for millions of years. Deep inside your brainstem sits a cluster of cells that most people never think about. Scientists call it the pre-Botzinger complex. It is your body's breathing pacemaker. It fires a signal, your diaphragm pulls down, air rushes in, and you never once had to think the word breathe. Your brain built this system to be automatic on purpose. Ancient humans could not afford to consciously manage breathing while running from a predator or sleeping through the night. Evolution handed the job to a part of the brain you cannot access with willpower. But that same brainstem is covered in opioid receptors, and that is where the danger begins. Opioid receptors evolved for a good reason. Your own body makes natural opioids called endorphins. Dr. Candace Pert helped identify these receptors in the 1970s, and the discovery reshaped medicine. Endorphins are released when you exercise, when you laugh, even when you fall in love. They are your brain's built-in painkiller and reward system. Fentanyl was designed in a lab in 1960 by chemist Paul Janssen to treat severe surgical pain. It binds to those same receptors your endorphins use, but it binds up to 50 times more powerfully than heroin and up to 100 times more powerfully than morphine. Here is the part your brain never evolved to handle. Those opioid receptors are not just in the reward centers that make you feel good. They sit directly on top of that breathing pacemaker in your brainstem. When too much fentanyl locks onto those receptors, the signal to breathe simply stops arriving. Not slows down, stops. Researchers studying opioid overdose, including work published through the National Institute on Drug Abuse under Dr. Nora Volkow, describe this as respiratory depression, a clinical term for a very simple, very old betrayal. The oldest automatic system in your body goes silent, while the rest of you is often still conscious, still aware, for a few final minutes. Why does something this dangerous even exist outside a hospital? The amount involved is almost impossible to picture. A dose smaller than a few grains of salt can be lethal. Because it is so potent, it is also cheap to produce and easy to hide inside other drugs, which is why public health data from the CDC has tracked it as a leading driver of overdose deaths across the country in recent years. Think about that for a second. The same receptor system that lets you feel joy after a hug, that let your ancestors survive childbirth pain and traumatic injury long enough to keep their genes alive, is the exact same system that a single overpowering molecule can hijack completely. Your body was never broken. It was built for a world of natural endorphins in small, self-regulating doses. It was never built for a molecule engineered to be 100 times stronger, arriving all at once. That is the real danger hiding behind the headlines. It is not just a street drug story. It is a story about how the most trusted, most automatic system in your entire body, the one you have never once had to consciously operate, can be switched off by something your evolution never prepared you for. Tonight, you will breathe roughly 20,000 times without noticing a single one. Somewhere, that same automatic gift is exactly what makes this molecule so lethal.